Alright, this is 1.5 measuring and constructing angles. Student objectives, what you're expected to learn today. We're going to talk about different ways to name angles. We're also going to learn how to measure them and classify different kinds of angles. We'll talk about what it means to be a congruent angle. We'll learn how to use the angle addition postulate, and also we'll bisect some angles using a compass and a straight edge. Alright, so first we're going to talk about how to name an angle, kind of define an angle, and we're going to say that an angle is basically it's two rays that have a common endpoint. So if I just draw a line going this way direction and say another line going this direction, that intersection point right here, that is going to be what we would call the vertex. Okay, and then the two rays, instead of calling them rays, we're going to call them sides. All right, and then there's different ways to name an angle. The easiest way is to name it by the vertex. So we would just call this angle A, like it says right here. We could also pick a point on each ray. So we'll call this one B, and we'll call this point here C. And so we could name it going this direction. We can go from B to A to C, and we'd call it angle BAC. Or we could go the other direction. We could start at C and call it angle CAB. All right. The third option that you'll see sometimes is you'll see a number, small number kind of written inside towards the vertex. And so if I put a 1 there, this is going to be called angle 1. Okay, so I can call it angle A, I can call it angle BAC, angle CAB, and if there happens to be a number there, I can call it angle 1. Alright, now for this next part, we're going to have to define two different areas. And of course, the interior is going to be any point that's kind of sandwiched in between the two rays. So that would be this part. This would be the interior. All right, and then the exterior, of course, would be anything outside of those two rays. So all of this would be considered the exterior. I can grab my pen here. Exterior. All right, so we're going to look at an example real quick. A lighthouse keeper measures the angles formed by the lighthouse at point M and 3 boats. Name the 3 angles shown in the diagram. Now, for this particular example, I cannot just call them angle M because I wouldn't know which angle I'm looking at. We'd have to use the different points, or in this case the boats, to differentiate between the different angles. So my first one that I would use, so in this case I have to use the points that are on the rays themselves. So I'm going to have to use point J, point M, and point K for my first one. Okay, the other angle I could use is if I use boats K and L, so I would call this angle K, M, L. So when I do that, when I'm using the 3 points, I can tell which angles, I can tell the angles apart. Now the third one is if I look at these outside rays here, I would use angle J, M, L. Now again, I could go backwards. I could call this angle KMJ. That would still be the same angle. All right. The other thing I need to tell you when we're doing these things, I want you to watch what we're doing first and then go back and pause the video, write down what you feel is important, whether it's something I say or if it's something I actually write down. All right, also what we're doing kind of with these videos is I'm going to add in some practice problems for you to kind of double check your understanding. So when you come into class, you'll need to have these done so that we can check to make sure you understood what we were talking about. So for these, I guess, practice problems, you'll need to look at 1, 2, and 3 and name the 3 different angles. Okay, I'm not going to give you the answers here on the video. All right, this next thing we have is what's called a protractor postulate. And basically what this is someone came up with a way to measure these different angles. And so what they did is they decided to use the numbers 0 to 180 to measure these angles. The important part that you need to know here is that this right here, this little m stands for measure. So I'm talking about the amount of degrees in an angle. So when you see that little m, that means measure of angle AOB. All right, next, this hopefully should be some review stuff for you. These are the different types of angles that we have. Of course, there's acute angle, right angle, obtuse angle, and probably maybe if there's any that you haven't heard of, it would probably be the straight angle, which would just be, if I have two opposite rays, that would give me a straight line. So we could call a line and a straight angle. For our purposes, they're going to be the same when we're talking about the measurement being equal to 180 degrees. All right, so real quick, we're going to kind of talk about how to use a protractor. Now, this little dot right here, that is where you would line up your vertex. It would go down here, like so. All right, now notice that there's this black line on the edge. You would have to line up either ray with that black line. So the vertex and this ray would have to line up. Okay? And then if you're reading from this direction, you're going to use these inside numbers. And if you're reading from this direction, you would read the outside numbers. So this angle right here would be about 64 degrees. Okay, and we'll talk about that here in just a second. I'll give you another example to look at. Okay, and here are these other examples that we're going to look at. Don't expect you to draw this compass out, but I do want you to watch and kind of see what we're doing. We're talking about this angle GHK. All right, so this is already lined up for you. Since I'm counting, or since I'm going this direction, I'm going to use the top numbers. Okay, so if I'm going from GHK, I'm going to read until I hit that other ray over here, which happens to be 125 degrees. So the measure of angle GHK would equal 125 degrees. Now if I'm looking at JHL, notice the ray HJ is this bottom angle, and then HL, ray HL is going this direction. So for this one, I'm going to read this way, which means I want to use the inside or the bottom numbers. All right, so JHL, I'm going to come from 0, I'm going to go up, and it looks like that one stops right at the 90 mark. So the measure of angle JHL is 90 degrees. And now I need to look at LHK. For this one's a little different because it's not at 0. So what I have to do is I have to look at the 90, and I'm going to use this side over here. So this one's going to be 55. That's at the 55 degree mark. So what I need to do for LHK is I need to actually subtract 90 minus 55, which ends up being 35. So the measure of angle LHK is equal to 35 degrees. Next we're going to talk about congruent angles. Now on a diagram, you'll notice there'll be these little kind of like tick marks that we have for segments. They're arches. So you'll have arches to tell you which angles are congruent to which one. So up here, angle G has one tick mark. And it might be a little hard to see on the screen, but angle B here also has one tick mark. So on this one for A, I would say angle G is congruent to angle B. And then also F right here has two arches. Angle D has two arches. So that would mean that angle F would be congruent to angle D. All right. So if we look at angle for B, part B, the measure of angle ADC, so that's this angle. So if this is 140 degrees, what is going to be the angle measurement of angle EFG? Well, since they both have the same number of tick marks, that means that the angle EFG is also going to be 140 degrees. All right, the next thing we have is what's called an angle addition postulate. Now, it's very similar to the segment addition postulate, where I can take a segment, and if there's a point in that segment, I can split that segment into two different parts. So on an angle addition postulate, I can take an interior point P, right, and if I draw a ray from the vertex to P, that divides the angle into two different parts. Those parts may or may not be equal, but it doesn't change the size of the angles. So I can take this angle RSP and I can take the angle PST. If I add those two, it's still equal to the sum or the measure of this outside angle here. All right, so let's kind of look and see what this angle addition postulate means. Now, if I take, so I have this angle LKN, and notice this ray right here, KM, kind of divides that angle up into two smaller pieces. So I can take this given information. I know that the outside angle LKN is equal to 140 degrees. That means I can take my 2x plus 10, add that to my 4x minus 3. Those two have to add up to be 145 degrees. All right, so I'm going to go ahead and solve this. I need combined like terms. I have a 2x and a 4x, which makes 6x. Then if I look at the plus 10 minus 3, that's going to give me a plus 7. Okay, then I would subtract 7 from both sides, and I'd get 6x is going to be equal to, let's see, this is going to be, oops, it should be minus 7. That's going to give me 138. Now divided by 6, that's going to equal 23. Now notice again, I'm not done because it's actually asking me for the angle measurements, but I need x so that I can substitute. So the measure of angle LKM is going to be equal to 2 times 23 plus 10, which comes out to be 46 plus 10, which would be 56 degrees. Okay, and then for the other one, the measure of angle MKN, it's going to be 4 times 23 minus 3. Or you could also look at it, since you know the sum is 145, you could also do 145 minus 56. Either one is going to give you the same thing. Those two things are equal. And in either case, you end up getting that this angle is going to be equal to 89 degrees. All right, so those would be your final answers. All right, here's another couple problems that I want you to try on your own just to check to see if you can do them. I do want you to draw this out and work this problem here, and then you also have this other one right here. One thing I didn't mention in the video earlier, just to kind of help you out, remember that this right here, this little red kind of square right there, means that this angle is equal to 90 degrees. All right, so I will give you that. All right, and then the last little piece on this part of the notes is going to be bisecting angles. And there's this word right here, angle bisector. Basically, that's a ray that divides the angle into two angles that are congruent. So this is the statement that you need to know. This ray YW bisects angle XYZ. So that means angle XYW is congruent to angle ZYW. Okay. This is going to be probably the common way that you'll see this given to you. All right. So you're supposed to interpret that for this drawing and see, notice the tick marks here that shows you these two smaller angles here have the same angle measure. All right, so let's look at this example here. Notice the statement, it looks very similar to what we have up here. QS bisects angle PQR. So the very first thing I'm going to do is I'm going to draw my angle PQR. All right, and I know QS bisects it, so that means that point S right here is in the interior. And it makes it so that these two angles are congruent. All right, and I know that PQS is 24 degrees. I want to find PQR. Well, if this part is 24 degrees, because it's a bisector, that means this angle here is also 24 degrees. So if I want the measure of angle PQR, I would just double my measurement, so that would be 24 times 2, and that would be 48 degrees. Okay, that would be my answer.